You're listening to 106.9 TuneFM, the home of UNE's student-powered radio. And joining me in the studio today, we have Dr. Nicolas Campione from geoscience and particularly paleontology. If you heard our orientation chat, you will recognize him as Paleo Nick.
That's me.
That is him. And we're going to be talking about a recent study that was published talking about dinosaur scales, feature scales specifically. So thanks for joining us today.
Oh, it's a pleasure.
So what was your role in the study?
Very well. That's a good question. So the role, at UNE, we have students at various different levels. I guess most of the people listening are probably undergraduate students.
You'd be surprised, actually.
Well, it's good, really good to hear. But we have a cohort of graduate students. And so this particular paper was led by Nathan Enriquez, who is one of our PhD students, currently almost done his thesis.
Soon to be Dr. Nathan Enriquez?
That is exactly correct. And so I guess our role as supervisors is multifaceted. Typically, as a supervisor, we have a project in mind. But the nice thing about PhD students especially is that as the project progresses, new sort of avenues come to the forefront, and the students are welcome to kind of lead those and kind of make them their own.
Yeah, cool.
So this particular one was actually kind of fun because Nathan and I were in the collections of the Royal Tyrrell Museum in southern Alberta in Canada.
Wow.
So him and I were there. We're probably going back now, I want to say 3 years ago. And we're going through, I was looking at my own stuff. He was looking at skin because his thesis is all about skin. And I'm just pulling drawers out looking for teeth, and in this particular drawer, I find this weird sort of blob fossil with odd-looking feet. They're scales, but there are odd features. Initially, we were sort of wondering what was going on here, and then as Nathan and I continued exploring it, it turned out that there was the skin of a specimen of a Procerolophus, a duckbill dinosaur found back in the 80s. And so we kind of discovered that, the skin had never been described for it.
Wow.
And so, and in addition to that, we had another specimen at that museum that was a juvenile. And so for the first time, we really had a chance to look at growth in skin, which is something that was never possible before.
Yeah, because I mean that's sort of the thing with dinosaurs is we often just see their bones. The paleo art that we see associated with them is changing.
Correct.
Over the years. I remember when I was a kid, it was very like skin tight and lacking, the muscle and the fat and all of those things like that. How hard is it to actually study dinosaur skin and scales? Like I know we've seen some specimens have been found with like feathers or odd scales, but not many. No,
I would probably say that less than 10% of the known diversity of Mesozoic dinosaurs are known with skin impressions or fossilized skin. So that means that over 90% of the dinosaurs that we see out there, we have no knowledge of what their integument, which is the fancy term for any kind of covering. The vast majority, we do not know anything about them. Yeah, wow. But we can sort of like make educated guesses based on other things, based on like modern day relatives. We can use modern day relatives. The other thing that we can do is we can look at the evolutionary tree of dinosaurs and sort of reconstruct patterns based on what we do have. So even though we may have, less than 10% known, that percentage does span the wide range of dinosaurs, and so we can then reconstruct ancestral states, for instance, and kind of trace it down the evolutionary tree and start making hypotheses about where particular features may have evolved, for instance. So where did feathers evolve? Where did feature scales evolve? Where did all these other sort of aspects come into play? Because feature scales, that's sort of the one that this specific study that Nathan and you and I believe Phil Bell published as well is sort of the main focus, and they're looking at the images associated with the study, the sort of rounder, bigger scales than the ones around them. What? I mean, I feel like I may have described it as someone who doesn't know much about. No, you did a good job there. What is a feature scale? Yeah. Is it just that, or does it serve a purpose? Part of the study and part of the implications of this work is to get at the nuts and bolt of what a feature scale is, because the reality is that there are no reptiles today that have these similar kind of features. The closest that we can think of would be, say, something like an iguana. I was going to say like an iguana has that on the shoulder, just like there's a couple of one. I guess there are some cases, but what the dinosaur feature scale seems to be a pretty unique thing. And so one of the hypotheses that we had was that, we worked on duck-billed dinosaurs and horned dinosaurs in this particular study, and both of those groups of dinosaurs are well known for having exaggerated features. Think of the horns, think of the frills, think of the crests. And these features come as a result of maturity. They don't occur in the juveniles. They grow these features as they get bigger. An analogy would be, say, something like a deer, moose, or anything that has antlers, for instance. These things don't occur in the juveniles. They grow in the adult. And so they're associated with maturity. And so one of the hypotheses that we had going into this was, maybe feature scales are also associated with maturity, and that maybe these things were become more prevalent as they get older, and they were associated with some sort of intraspecific, so within a species, some sort of interaction. But what we found in the end was that no, the juveniles have feature scales as well. And not only do they have them, the relative size of the feature scale is pretty consistent across the growth series of, across a juvenile and an adult example. Because at the end of the day, we still only have two samples to look at, because that's the nature of the game. But either way, those two were very consistent. And so, at least from the perspective of the shape and size of the feature scale, it seems like it's not associated with the growth of these animals or maturity. But of course, we can't reject that color may have played a role. We have no notion of at this point. So.
That's because my understanding is that skin and soft tissue is much, much harder to preserve in the fossilization process through varying degrees. I haven't even considered the idea of how color would be preserved.
That's right.
Is that even possible for that to happen?
In a way. So what has been kind of discovered over the last, I'd say, maybe 5 years to a decade is that certain colors, structural colors, things like melanosomes, can be preserved. That doesn't give you the true color, but it can be used as sort of a relative color. So think of darker versus lighter colors. Those aspects have been interpreted and can be interpreted. In the specimens we were looking at, we didn't have any of those. We did, as Nathan did, look for them, but they were not there. So at this case, we couldn't really discuss color at that point. It was a moot point. But color is coming into the forefront of study in paleontology, and as we collect more fossils, as we go and as we expand our sample size, the hope is that we can then get better and better understanding of some of these aspects and get an idea of the full range of varieties that we get across dinosaurs.
Yeah, and hopefully maybe find some other specimens with the feature scales as well.
Yeah, absolutely.
Because, I know that the modern day equivalent of a dinosaur, I feel like it's a joke, but also largely true, it is birds, right? They're sort of the almost direct descendant.
Well, they are direct descendants. Yeah. So
and if anyone's ever seen a cassowary,
birds are dinosaurs.
Yeah.
So.
Which is, I think, crazy to think about sometimes. And then, I don't know, I grew up on a farm. I've witnessed chickens run after a mouse and slam it against a wall to break its neck and eat it. They're terrifying things.
And not only are modern birds dinosaurs, they're actually theropods. So they're of the meat-eating side of the dinosaur tree. So
that's right, because there's the herbivorous side as well. Yeah. And omnivores? Were there omnivorous dinosaurs? Yeah. But, you talk about these feature scales, and I think of whether or not the area that those scales are on is associated with the size and shape. If you think of chicken feet as an example, the scale sizes and their shapes are very specific to the movement of that body part. Do these feature scales have an association with the potential musculature and the way that those body parts move?
That's a very good question. I think we don't really know how these might be associated with motion. We do know that these feature scales are only on certain parts of the body, so we're not likely to find them on, for instance, the ventral, the stomach area. They're more likely to be on the sides of the body. But even then, we still also don't understand the full extent of these scales on the body, because the reality is that most fossils are not discovered with their full scale intact,
True.
the first full skin intact. So we'll find a chunk of skin. If we're lucky, we can associate that chunk of skin with a part of the body. So that gives us a sense of that part of the body, but it still won't give us the full extent of the animal.
Yeah. What is the largest portion of skin that has been discovered so far?
I'd probably go with one of the famous mummies that was discovered. So there's one at the American Museum of Natural History where you have major swaths off the side of the animal that have you can see wrinkles, you can see the feature scales, you can see this is an Edmontosaurus. Other than that, there is a specimen known as Leonardo in Montana. It's a Brachylophosaurus, another duckbill dinosaur. Yeah. It is also known from a very complete set of skin.
Was that one named after Da Vinci or the Ninja Turtle?
That I do not know.
To be fair, I suppose either way, the Ninja Turtle's named after Da Vinci.
Maybe, so, absolutely.
But at least if people are interested, that's a name they can go and look up, Leonardo the dinosaur.
That's right, Brachylophosaurus canadensis is the species.
I'll get you to send me the names so I can write them down in the show notes for people how do I spell
It's one of the longest names of dinosaurs.
Yeah. But, they're such cool creatures, and we know... I feel like we know a lot about them, but not nearly enough.
There's always more to do.
Always more.
And I think that what we try to do here at uni and what Phil and my lab do is we try to take some of these fossils to the next level. How do we understand it from a more biological perspective, and try to get a sense of these animals as creatures and not just cool discoveries, which they still are, of course. And we always want to go and find more stuff. But we also want to understand these animals from their sort of living perspective.
And it's I feel like as humans, we really strive to understand things like this. And I feel like dinosaurs have captured our imagination for centuries. Dinosaurs and their remains probably directly impacted the dragon. These
100%.
Big lizards that we don't see anymore.
Humans have been
every culture.
Absolutely, humans have been finding dinosaur fossils and other prehistoric creatures since humans were around.
Yeah.
And so they've always had hypotheses and ideas of what these things were in various different, and of course it was dependent on whatever kind of way of thinking that they had at that point in time. But absolutely, right now we teach the Western sort of history of dinosaur research, but it is way older than Richard Owen's naming of Dinosauria. So
yeah. So you mentioned the Western history of dinosaurs. Is there a difference between the Western history and sort of Eastern, over in Asia, in how they look at dinosaurs?
Well, not right now. Right now, we've all I think most groups right now kind of fall in line into the modern sort of taxonomic paradigm of describing dinosaurs, and we've moved away from names having to be Latinized and Greekified, for instance, and so a lot of Chinese dinosaurs nowadays have Chinese names.
Oh, fantastic!
They're still written in sort of our alphabet, but they're entirely Chinese words. And there are actually no rules now about those things. As long as they're using a common alphabet, any language can be used for naming any organism these days.
Yeah, wow. Because, you think of traditional scientific names, most of what I think of outside of very recent ones, like there was some isopods that were named after Darth Vader's helmet recently, or there's this one guy who keeps finding spiders and naming them after celebrities, kind of thing. They're all very, very Latin and Greek to describe the creature and its role and its idea and things like that. But I'm curious because, we mentioned the Chinese dinosaurs and the Chinese names. Is there an area that dinosaurs are most commonly found? Because I know at UNE, you guys often do trips over to Mongolia to study in the Gobi Desert, and that was, I think, where was some of this study conducted over there as well as part of this specific paper?
This specific paper, no, because it was all Canadian dinosaurs, so Procerolophus and Chasmosaurus. So Procerolophus, the duckbill dinosaur, Chasmosaurus, the horned dinosaur. So this particular study focused primarily on Canadian stuff, but fossilized skin is common in Mongolia as well. Last year, Phil and I went to a site called the Dragon's Tomb, and that has a relative of Procerolophus called Saurolophus, and that site is covered, there's skin everywhere in that site.
Wow.
So it's a great place to find big chunks of skin, sometimes associated with the actual body parts of the animal.
Yeah. What makes it such a special site to preserve skin? Is it just like the dryness?
At the end of the day, for fossils to be the best that they can, we need them to be buried as fast as possible. And so if you find an articulated fossil, there is a high chance that fossil will have skin on it because it was likely buried very quickly, soon after it died. We're talking maybe, weeks or months from death. Because decomposition it acts fast, and so any kind of time that it's kind of sits out, it's going to get scavenged, it's going to get destroyed, and then we may get a bone down the line, but most of the animal will be gone at that point, and definitely no skin. In this particular site, Dragon's Tomb, or the fossils that we're talking about that Nathan described, those were all found in articulation, nicely detailed. So all of these are examples of animals that were buried very quickly, and so there's a high chance for the skin to also be preserved. So
I guess sand dunes, that a big enough wind that'll very quickly bury something.
That's an interesting one. Sand dunes, because in Mongolia, there is a particular formation called the Djokta Formation.
Yeah.
And it is a series of sand dunes. And we have examples of collapsed sand dunes. And we actually have examples of really nicely preserved Protoceratops and Velociraptor that they died basically in mid-posed.
Wow.
But no skin, as far as I know, from that formation.
Interesting.
So I wonder if the sort of the geochemistry of the sand dunes they still decompose, but the bones are kind of left there in their original form.
Something to do with like the abrasiveness of the sand.
Maybe, yeah. It's an interesting. I may be wrong, but I think thinking about it, I don't think the Djokta preserves skin per se.
Yeah.
And in fact, when we were there, we found a bunch of articulated Protoceratops, but again, it's just the bones.
Yeah.
So.
That's very interesting. And students have the opportunity to go as
Indeed.
well.
That's right.
Tell us about that.
Yeah, so we went last year, and Phil and I are hoping to make this a yearly event. And so we are currently looking for interested people who want to come to Mongolia and come. The dates that we have right now are the 10th to 24th of September. And we'll be going to a few different sites than when we went last year, but it is the Gobi Desert, and it will be it's almost 100% chance that you will find stuff because there's just dinosaurs everywhere there.
Yeah. And is this specific to UNE students studying paleontology, or any UNE student? Do you have to be in a specific unit?
Oh, well, actually, at this stage right now, it is entirely open to the public. So anybody can join. This is through Mongolia Quest, which is the company that sort of, they run the logistics side of things, and then we run the scientific side. And so right now it's open to anybody. We're hoping over the next little while to actually make it a more UNE official thing for students. So I guess keep an eye out for any kind of communication. But at the end of the day, if you're curious and you haven't heard anything much about it, feel free to reach out to any of the paleontologists at UNE. They'll be able to send you in the right direction.
Yeah, awesome. And that's specifically through Mongolia Quest. It's not gonna go towards like an extracurricular marks or anything.
Well, we're trying to make it so that it actually counts as as credit.
Yeah, probably not this year though.
Let's put a pin in that.
Yeah, okay.
It's a lot of work to get it set up.
Yeah, I can imagine.
The goal is to make it as soon as possible, and if we have our way, it will be this year.
Yeah.
So
if you're planning on studying the dinosaurs unit, which brilliant unit, mind you, great chance to put it in action.
Absolutely. Yeah, dinosaurs runs in T2.
Yep. So you've got time to enroll.
That's right. You have plenty of time to enroll, and in fact, the end of so September is roughly the end of T2. So you could do you can do most of the dinosaur unit and then come join us in Mongolia, for instance.
There you go.
And then get a first-hand experience of it after doing most of the unit. And maybe because you're traveling, maybe I'll forego any kind of late assessments at that point.
Yeah. You're helping out with the discovery, so
Yep, absolutely.
things maybe can slide.
That's right. I'll take this into consideration.
Yeah.
That's right.
Yeah, well, I feel like we've sort of covered a lot of it. The article, it's up on UNE, which links to the specific journal. So if you do want to read it in full...
Journal of Anatomy, and it is open access, so anybody can download it.
And, very interesting, really makes me start thinking about dinosaurs again. And, you feel like a little kid when you're like, oh, what's it going to be like? What do we got? So... I would say if you are interested in dinosaurs or you just want to feel a little bit nostalgic, check it out.
Absolutely.
Support the great work that our PhD students are doing, that our lecturers are doing. And if you're interested in dinosaurs, if you've got an elective or if you're doing something associated with paleontology, check out, the unit in T2.
Yep.
And check out the Mongolia trip.
Yeah, please do.
Yeah, because you and Phil go to Mongolia very regularly, like every year, you said.
Yeah. That is the plan.
Great working relationship with Mongolia Quest and academics over there as well.
That's right. Yeah, we always have a Mongolian paleontologist that comes with us, and then there's always other research groups from around the world. So we have colleagues from Canada, colleagues from the States that are also doing fieldwork in various different parts, and so it's a cool place to sort of meet other paleontologists. So.
Yeah, great for networking.
Absolutely. Yep.
So, yeah, thank you so much for coming on, Nick. And again, I encourage you check out Nathan's paper, check out the work that Nick and Phil and everyone else is doing, and join their units. Is there anything that I haven't asked or any cool facts that you want to drop before we wrap up?
I'm on the spot now, so I have to think right now. I can't think of anything.
Fair enough. That's my bad. Well, thank you so much for joining us.
Yeah, my pleasure.
And thank you all for listening here on 106.9 TuneFM.